Thank you, Sean, for the introduction, and thank you for all of those attending today's orientation. So this is session B of a two-series orientation session. It's recommended that you attend session A as well. So if you haven't, I'll point you to the recording from a training portal that we have in the Enclave. But we'll be reviewing some of the materials from session A, so you'll be able to follow today's presentation. If you have registered to N3C and have an account created, this session is for you. So it's primarily for people who are new to the Enclave or people who with some exposure to the Enclave and want refresher. So hopefully will you find this session useful. And this is going to be practical. So we're going to cover some of the tools and do some data analysis examples in the Enclave. And this is not going to be covering all the features within the Enclave. So it's not an in-depth overview, but will provide additional resources and documentations and show you ways to ask questions if you have further questions when you work within the Enclave. This is roughly the outline. So we're going to start by giving some navigation tips, which are mostly refreshers from session A. And then we're going to talk about concept set tools within the Enclave and how to use them to do data analysis on EHR data within the Enclave. And we're going to cover a little bit code workbook, which is a code-based tool within the Enclave if you prefer writing code in R or Python or SQL, for example. And lastly, we'll mention some other apps such as the Phenotype Explorer to understand the cohorts and phenotypes that exist within the Enclave. So switching to the homepage. So this is what you see when you log in to the Enclave. You have some statistics about the count of patients that we have on the Enclave. So 5.5 million patients in total, 1.5 million COVID positive patients. And then you have some statistics about the number of procedures, drugs, visits, observations, and lab measurements. So this is to give you a feel of what exists within the Enclave. If you actually scroll down a little more, you have more information about the breakdown of the cohorts that exist in the Enclave by gender, by age, comorbidity distribution, and you have some basic statistics. And then if you click more, I'll talk about this later, but it will take you to an app called the Phenotype Explorer, where you can have more statistics about the patients available within the Enclave. So going back here, usually when you join, when you register to the Enclave, you either create a new research project and have access to level 1, level 2, or level 3 data, or you join an existing project, an existing research project. And the way to do that is described in this link here, Data Access Overview. So I'm not going to talk in details about this, but this is where you find information on how to access different levels of data and how to join existing projects or create a new project. So that's a link from the homepage. Now, the other thing that is useful from the homepage, especially for people who are new to this platform, is this link to training materials. So if I click on it, there are a few different ways to get up to speed and get trained within the Enclave. The first one is called the training portal. And what the training portal is, it's basically a collection of training modules. Some of them are short and some of them are longer, which are N3C specific. So with the context about the data. So essentially you will have some training modules on how to get oriented within the Enclave. So each one of these are training modules. If you click on them, you will get some information about the learning objectives and the topics covered, the estimated time to complete. And generally, the training module is either a video posted on YouTube or a documentation report or some other tutorials. So you have trainings about OMAP, which is the common data model that is used within the enclave. If you're not familiar with the tables and the fields, you can take one of these training modules. And then you have some, for the orientation, session A is basically recorded here. So if you haven't attended session A, you can click on this one. And then you have some basics and some more advanced training modules. So this is very useful to get up to speed. The second training resource that we have is what we call Academy, which are essentially self-guided short tutorials that you can follow along. So we have a number of tools that do data analysis within the enclave, and I'll talk about them in a bit. Some of them are called, one of them is called Contour, the other one is called Code Workbook. So as an example, I can take this Academy tutorial to get the basics of Code Workbook. And this is self-paced and you can follow along. So if you click on Start Tutorials, you can follow the instructions here. So it's telling you click on Projects and Files, which is here. And then every time you accomplish a step, it checks it. And these are some short tutorials to get up to speed quickly. And then the last training resource that I wanted to mention before starting with some examples is this, what we call platform documentation, which is more in-depth documentation about all the tools and features within the enclave. So this is when you get a little bit more advanced and get the basics, but still want to understand the features and what you can do. So for example, you have a documentation about Code Workbook here, where you have some basics and context, and then some quick tutorials and more references about how to use the tool and how to write code, etc. And then lastly, if you're having trouble, well, I'll talk about it in a second when I cover this sidebar. So this expandable sidebar is where you have some links to the most useful applications and most useful resources. But before talking about it, let me just talk a little bit about some of the applications that we put in the homepage. One of the useful ones is called the data catalog. And so if you click on it, this is where you find the collections of the most useful tables and data sets within the enclave. So for example, if you have level 2 access or de-identified access, there's the de-identified data collection. If you have LDS access, then you can check out the LDS data collection, which is a collection of tables that contain EHR data in the OMAP format. For the purposes of this presentation, we're going to be covering notional data called Cynthia notional data. So it's a collection of tables which are the same format as the level 2 and level 1, level 2 and level 3 data sets that we have in the enclave. But this is notional data, so it's not real data, which is why we're going to be covering it today, because I can show the content of each table. So going back to the homepage, if you look at this sidebar here, which is expandable, this home takes you to the homepage. If you click on projects and files, this is where basically all your work, the work within the enclave is organized in projects, which we call research projects. And every group of people, every group of collaborators have their own research projects, which are here. So if I start typing something like, just for example, this is all the research projects. So you will have access to not all of them, but only the ones that you requested access to. So just as an example, I'm going to start typing orthopedic and I have these two matching projects. So maybe your project is one of these, and if you click on the project, you will have, this is where you save all your work. So all your data is saved here, or your analysis and results and reports will be saved on in your research project. And so you have the research projects here, you have the data catalog, which I talked about already. There's some useful features to look for resources if you don't know where they are in the enclave, and one of them is just the search bar. So if you don't know where a data set lives, in which you don't know in which project it lives, or whether it's in the data catalog or somewhere else, you can use the search bar to search for that. So for example, if I start typing something like drug exposure, if I'm looking at searching for the drug exposure table, I get all the matching results here. And here I have several tables, and each one is saved on a different path. So you can search for tables using the search bar. You can search for folders. You can search for analysis. So this is a quick way to look for what you need. In here, you have all the available apps within the enclave and tools. So you won't be using all of them. And the most popular ones are Contour, which is a point-and-click data analysis tool. Code Workbook, which is the interface or the editor if you write code to do data analysis. Reports is when you create reports to either describe your analysis or share results or publish results. And Fusion is a spreadsheet that is embedded within, is a spreadsheet tool that is embedded within the enclave. But there are, if you click on View All, there is a larger number of these applications. But I'm just going to be covering today the most useful ones. So Contour, Code Workbook, maybe Fusion, and reports. Going back, so if I go to the data catalog, and then I want to explore the Cynthia notional data, which is the collection of all the domain tables. By the way, if you're curious about what the data contains and some information about these tables, there's a README file here that explains the content of these tables and the process, how we basically brought them from outside the enclave into the enclave. But let me just, for example, explore some of the tables. Let me click on this procedure occurrence table, which, as the name suggests, is a table that contains the records of all the procedures. And so as you can see, when we open the data set, so I use data set and table terms interchangeably within the context of the enclave, but they essentially mean the same thing. So we're looking here at a data set called procedure occurrence, which is basically rows and columns that you can explore. And on the right-hand side, you have some metadata that describes what this data set is. So you can see when it was updated and the person who updated the data set, when it was created. This is the path or the location where it's saved within the enclave. And this data set is 19 columns and 800,000 rows. And you can also, something that is very useful within the enclave is you can track the provenance of the data set, meaning that for each resource and each data set, you know how it was created. And so this one was updated by this analysis, which is a code workbook analysis. So if you click on it, and I'll cover code workbook a little bit later in this presentation, but just to give you a feel of how it looks like, this is basically code that created this table and the logic that created it. And then the last thing that is useful for provenance is you can also look at the inputs. So this data set was created from this other input, also called procedure occurrence, saved in this location. And so some useful things when you navigate and explore a data set that you're not super familiar with, you can use this search column. So you have the list of columns on the left-hand side here, all the columns with the types and some statistics. But you can also use this search column bar. So if I start typing something like name, it filters to only the matching columns that have the string name in their name. And so something I can do is, for example, if I click on the header of this column called procedure type concept name, automatically I get some statistics about the content of this column. So this one only has one value. Trying to find another example where we have multiple values that we can explore. Oh, there you go. This one, procedure source concept name. So let me go back to it. So this one has multiple values in them, and you can see that it's only 126 distinct values. What I can do is maybe I want to focus on just this one called oxygen administration by mask. So if I click on it and I click on this filter, it will automatically filter. Let me remove the column filter. Right now, we're only looking at the records that correspond to for which the procedure source concept name is equal to oxygen administration by mask. So that's just one way to explore the data. I'll show you more ways to explore and analyze the data when we talk about contour. But first, now that I've showed you some of the domain tables, so if I go back to the data catalog, simply a notional data, this is the collection of the domain tables, the OMOP domain tables. So you have conditions, you have death, person is the demographics, you have measurements, you have drugs. And so the question that is important to answer is, how do we filter these domains, given these domain tables, conditions, measurements, procedures, or say medications, how do we filter them to define the relevant electronic health records or cohort to study so that we can do our analysis on what we're interested in? And this is where what we call concept sets can be useful. And so a concept set is an important term within the enclave. And what basically it is it's basically a set or a collection of concepts or defined by concept IDs from the OMOP vocabularies that are used to define phenotype. So examples could be, a concept set could be a list, for example, of condition codes that are used to define chronic kidney disease, or maybe a set of codes that correspond to lab tests for white blood cell count, or that corresponds to PCR lab tests for COVID. And so within the enclave, and let me go back to the homepage. Within the enclave, we have already a number of defined concept sets, and they were defined by researchers like you and other users for their analysis. And these concept sets are recorded in the enclave, so you can explore them and reuse them. And the application that lists all these concept sets is called the concept set browser, also available from the homepage. So if I click on concept set browser, what you see here is a list of all the concept sets that are defined within the enclave. And you have some useful filters here that you can apply. So for example, you can just look at the concept sets created by a specific person or assigned to a specific person to review, or you can just use the keyword. So if I type, for example, the keyword PCR, what I see here is two matching concept sets. If I click on this one called Atlas SARS-CoV-2, RT-PCR and antigens, you can see that there are two versions of these concept sets defined by these two people. Let's look at the latest one. And so when I click on it, I have some metadata and properties here. So it's uniquely defined by this ID that we call code set ID. This is the name of the concept set that we're looking at. And if you scroll down, you have some useful information, such as where this concept set was used in these 3 different research projects. This one called cohort characterization, this research project, and this one called orthopedic surgery. It has been used to define these 3 cohorts. And more importantly, you can look at the content of this concept set. So if you click on this tab called OMAP concepts, you can see that it has 55 codes or concepts within it. Most of them are from the LOINC vocabulary. Some are SNOMED. And you have the list of all the codes or the concepts within this concept set. So you can see the information. So most of them are, in this one, most of these codes are lab tests, but you can click on one of them and just get more information. So this one in particular is a lab test. This is the name of the concept, and it's defined by this concept ID, and it's coming from the LOINC vocabulary, and it is a standard concept. So again, the concept set browser is a list of all these concept sets that you can explore and maybe reuse for your analysis. Now, the question is, given a concept set in here, how do we use this in practice? And so how do we use it in practice in an analysis? And let me go back again to the data catalog from the homepage. And there is one table. So if I click on data catalog, there is a table in this collection called OMAP code sets. Code set is another word for concept set, called concept set members. And this is the table that has the list of all the concept sets defined within the enclave. And for each one of these concept sets, it has the associated codes or the associated concepts. So each concept set is defined by this code set ID or the concept set name. And each code set ID has one or multiple concepts defined by the concept ID or by the concept name. So this is the table that is back in all these views that I've been showing you here in the concept set browser. But in order to use this in an analysis and use it in conjunction with other domain tables, we can use one tool called Contour for data analysis. So one way to access it is to click on this blue button, Analyze, but you can also access it from here. So if I click on Analyze, I'm basically asking that I analyze this concept set members table in the tool called Contour. So Contour is the point and click analysis tool within the enclave. So it's a tool where you can analyze the data without necessarily writing code. And so my starting point here is this table, concept set member. And as you can see, it has, almost 3 million rows and 7 columns. And in order to start exploring it and analyzing it, there are a number of boards. So these we call boards that you can use to analyze the data. So some of the most useful ones, if you click on Visualize, you have a number of boards that you can use. And one is just like a plain table. So a table board just gives you a preview of what the table looks like before analyzing it. So you can see here the rows and columns that are within this concept set members table. And another popular board is the histogram. So if you want to explore, get some statistics about the data, one thing I can do is plot the code set IDs in a histogram and look at the counts of each code set or each concept set. So as you can see here, these are all the concept sets. You can click on show more to get more, and then you can show all the records. You can explore them in here. And each one of these concept sets defined by concept IDs have a number of concepts within them. So you can see that this one, for example, 456781480 concept set has more than 47,000 concepts within it. And you have large concept sets, and you have other ones. If I sort by ascending, I have some smaller concept sets. This one has only 153 concepts within it. So one thing you can do with this histogram is, if you click on it, it's interactive. So if you click on this bar, it will automatically apply a filter. So now we're only looking at the records for which the code set ID equals to this number. And so if we do another table board at the bottom here, you will only see the filtered table corresponding to this filter. So it's only this code set ID. And one thing I can do, if I click on calculate summary, or there is also a board called the summary board, which is the same thing. It gives you a count of the number of rows after applying this transformation. So it'll take a few seconds to load. And now you can see that we only end up, after applying this filter, with 43,000 rows. And if we click on here, it will remove this filter, and now this will update to the original count, and it will automatically update. So something useful that I can do is, I may be interested in a specific concept related to, say, pneumonia. So what I can do here is apply a filter, and let's say I only want to keep the so something I can do here is, instead of looking at the concept sets, let me change this to look at the list of concepts defined by their concept name. And so as you can see, you have a large number of concepts within this table. And let's say I'm interested in the ones that contain the keyword pneumonia in them. What I can do here is apply a filter on concept set name and say, keep only the records for which concept name. So I want to keep only the records for which concept name contains the keyword pneumonia. And I want to make this case insensitive. So if I click on save, and then let's calculate summary to see the resultant records. And at the same time, I want to look at a histogram. So I want to look at a histogram for which on the resulting concepts. So as you can see, we end up with 22,000 rows. And now all these concepts I'm looking at right now have pneumonia associated with them. So maybe that's one way to define the concepts that only are related to pneumonia, if that's what I want to study. But the problem with this approach of matching by string is that it can be inaccurate. So maybe I'm including some of the concepts that I don't want to include, or maybe I'm missing some other concepts that are important to my analysis. So maybe a better way, or a better practice to define your list of codes is by using the concept sets. So if I go back to the concept set browser, and let's click on concept set browser. If I look for the keyword pneumonia, you can see here that a number of people within the enclave define these concept sets that are related to pneumonia. For the purposes of this training, I'm going to be using this one, this concept set non-influenza pneumonia that Sean defined. And so this concept set only has one version. And one thing that is useful for my analysis is this code set ID. So this is what I am going to be using in my contour analysis. So if I grab this code set ID, and then I go back here, and now instead of doing a string search, what I want to do is keep only the records for which the code set ID equals to this number, which corresponds to my non-influenza pneumonia concept. If I go back to my concept set, non-influenza pneumonia, you can see that it has 221 codes or concepts within it. So hopefully when we filter, we get the same number. So now if I click on calculate summary, what I have is indeed 221 rows or records corresponding to, let's add a table board here. So these are all the records. And if I add a table just to look at it, look at all the rows, you can see that this is the, I'm only keeping my non-influenza pneumonia concept set. And these are all the concept IDs that are within this concept set. And this is the name of each one of these concepts. Now that I've defined the list of concepts that I want to use in my analysis using the concept set non-influenza pneumonia, the next step is to get the corresponding records from the domain table. And since this is a non-influenza pneumonia is a condition, so all these, if I go back here, all these concepts are basically conditions. So from the domain ID is condition. The corresponding table is called condition occurrence. So this is where I'm going to get all the list of conditions that are within this concept set that correspond to one of these conditions. So in order to do that, I'm going to apply a join board to bring in the condition occurrence table. So if I click on join and choose dataset, I'm going to grab this dataset from the enclave. And today, obviously, we're using the notional Cynthia data, which is in the data catalog. If you have level 2 or level 3 access, you'd be using de-identified beta or LDS beta. In our case, we're going to be using this notional data. So if I click on it, let me grab the condition occurrence table. And before performing the join, let's have a quick look at this table. So let me open it on a separate tab. And so what I see here is there's this column called condition concept ID. So this is all the concept IDs for all the conditions that are in this table. So this is the column that I am going to be matching on and performing the join on, condition concept ID. So going back to my analysis, what I'm going to do is add all the columns from this table. And my matching condition is going to be match all the concept ID from my left table is this one, is the concept set members table. So I'm going to match concept ID with the condition concept ID from this condition occurrence table. And in my case, I only want the record that are strictly equal to these concepts. So I'm going to be performing an intersection, which is another word for inner join. So if I do that and click save, what I have here is the resulting records are 17,500 records corresponding to my concept set. So I went from more than 80,000 rows in the condition occurrence table to 17,500 records corresponding to my concept set non-influenza pneumonia. And I can have, if I click on on table board, I can look at the results. So you can explore all my results in here. So you have the condition occurrence ID, the start date of the condition, the end date. So all the information about this condition. So while I'm doing that, let me actually save this analysis. So in my folder, so let's call this N3, let's call this lung influenza pneumonia analysis. And let me save it in. So in your case, you'll have access to a specific research project, so you'll be saving it in there. In my case, for the purposes of this presentation, I have created a folder called N3C orientation. And this is where I'm going to be saving my analysis. So let me save it in here. And so this way, if you log out and then log into the enclave, you can go back to your N3C. You can go back to your folder and you will find your analysis saved here. And you can open it and continue working on it. So nothing is lost when you do actions in the enclave. The other thing you may want to do is you can also, let me click on view to have a better view of the analysis. You can make this analysis as favorites. And what this does is it will show it on your sidebar here. So as you can see here, it added my analysis as a favorite on the sidebar, so I can have quick access to it. So I have a number of favorites here. You can customize it. You can favorite folders, you can favorite data sets, and you can favorite analysis. So right now it says the document is locked because I have it open in this other tab. So let me close it and go back here. So another thing I can do is, as you noticed here, I started from a data set and then I performed a number of transformations. So I did some exploration using the histogram. Then I did a filter. I applied a filter and then I joined with another table. And so I have a result here. And maybe I want to save this result as a new data set so that I can reuse it in different analysis or reuse it in a code workbook. So let me actually name this data set non-influenza pneumonia results data set. And let me save it in my N3C orientation folder. And so now it's going to be saving. I have a link to this data set in here. It will take a few seconds or a couple of minutes to kind of like build and get the data. But essentially, it will contain the results, which are shown here. And you can access it, as you can see here. It's also saved within the N3C orientation folder. So now I have a saved data set and I have a saved analysis. So I'm going to go a little quicker on this contour demo just to show you a little more functionality and so that I can also jump to talk a little bit about code workbook and other tools before the end of this presentation. So one thing I can do here is maybe I'm interested in creating some reports so that I can show my results and collaborate with other people. But before that, let's create some visualizations. Actually, before creating a visualization, maybe something I want to show you how to apply transformations, other types of transformations to this data set. And one way to apply it is something called, if you click on transform here, so these are different ways to transform your data set. There's something called the expression board here. And the expression board allows you to write some simple functions or reuse some simple functions with a syntax close to SQL. And so I can define a new column and then write an expression here to say what the content of this column is going to be, or maybe just modify an existing column. So in my case here, I noticed that I have some columns. One is called condition start date and another one called condition end date. So maybe something I'm interested in is to define a duration or like a condition duration column, which is basically the difference between these two dates. So let's define a new column called condition duration. And there is a function here called datediff that you can reuse. So there are a number of functions that you can reuse. And if you click on the information sign here, you can get some documentation about what the function does. And I'll show you where all the functions are defined and the documentation for each one of these functions. But essentially here, just to go quickly, I'm going to do date diff, and I'm going to take a difference between my condition start and end dates. So if I start type in the column name, it will automatically autofill it. So I want to have the difference between my condition start and end dates. And if I click on apply and now show the results using a table board again, you can see that I defined a new column called condition duration. And it's an integer. Basically, it is the number of days between the condition start and end dates. So now that I have this column, let me plot a grid showing the distribution of this duration. So if I click on a grid, maybe something I'm interested in is looking at the relationship between conditions. So so I want to plot the condition in the x-axis and maybe the duration in the y-axis. And maybe I want to look at the count of patients. So the unique count of patients for each one of these variables. So each patient is defined by a person ID. So when I do that and I click on compute, maybe actually let's switch condition. So what I'm showing here is the duration as a function of condition concept name, which is pneumonia. I'm wondering why I only have one concept. Let me plot the condition duration in the x-axis.
Saad, I know why that is.
Oh, is it the Cynthia data that only has one condition?
Yeah, that particular
Okay.
data set is a notional
Okay.
fake data, and it's not as diverse as the real data.
Okay, no problem then. So this grid might not be as super interesting, but I can still show you the functionality. So what am I plotting here? Condition duration, sorry, condition concepts. So let's say maybe I have more diversity in the conditions. What I would be able to see here is a grid with the concepts and then the durations. And if this is an interesting result or graph, what I can do is create a report to add these results in here. And the way to do that is click on add report. And then let's create a new report and let's call it N3C orientation report. And I'm going to save it in my N3C orientation folder. So by doing that, it's creating, as you can see here, a report. And if I open it on a separate tab, right now the report only has this graph that I added. And I can, so basically a report is like an interactive way to show results. So the results could be either graphs or it could be data previews, and you can add the text to describe your results. So you can add some text here, you can format your results and have other people comment on it. So it's a nice way to present results and collaborate with other people in a report. Maybe another graph that I may be interested in is, let's say I want to add some demographics data, and especially, let's say I want to add the gender as another feature that I want to add to my report. The demographics data is in this person table that is in the data catalog. So one thing I can do here is, let me create a new path within this analysis. So every contour analysis can have multiple paths. You can think of them as like different tabs in Excel. where you can perform different type of analysis and have the paths interact. So from this path, I'm going to be starting from the person table, which is the table that has demographics. So if I go to data catalog and I go to my Cynthia notional data, let's add the person table. And let me visualize it using a table board. So as you can see, each patient is uniquely defined by this person ID. And in this table, there are some interesting demographics information. So for example, I may want to be interested in adding the gender information, which is in this column, gender concept name. So something I can do is go back to my other path, concept set members, and I want to join with the person table on the person ID to bring in the gender information. So if I click on choose dataset, instead of selecting the datasets from the platform, I can select the result of my other path, which is this one, person. And let's say I only want to bring in the gender column defined by gender concept name. And my matching condition in this case is going to be on the person ID. And since here we want to keep all the records from my left tables and only bring in the gender information if it exists from the person, I'm going to be doing an add columns, which is another word for left join. So if I click on save and then visualize the results, if I scroll all the way to the right here, I can see that I brought my gender concept name or gender column. So maybe something I want to do is, let's have a chart where I'm showing the condition. Maybe let's show the condition duration in the x-axis, and in the y-axis, let's show the unique count. The unique count of patients. And I'm going to be breaking it down by gender. So if I click on compute and save, let's actually show it in a different way, as a grouped way. So as you can see here, this is a chart showing the condition durations from 8 to 23 days. There's a breakdown by gender. So maybe I want to add this other graph to my existing reports, which I called N3C orientation report. It shows up here. So once I add it, if I go back to my report, as you can see now, I have this other table which I can format in here. So I can give it a title, maybe breakdown by gender. I can comment on it. I can make this a view-only report. And this is something that I may maybe want to share with my colleagues and write on it and collaborate on it. So something to note about this report tool is that it's interactive. So whenever the underlying logic that created these two graphs, for example, updates, or whenever the underlying data updates, these should update automatically. And you also are able to define some interactive parameters in here, although I'm not going to cover that today. But just to show you briefly, let's say, let me create a distribution of the condition durations and apply a quick filter. So maybe I only want to focus on the durations between 10 days and 13 days. So I can apply this filter here. As you can see, it automatically applied this following filter. So this chart will update. And as a consequence, this gender graph should automatically update. It might take a few seconds to do so, but it should look now like this graph if you refresh it. So as you can see here, it says that there has been some changes to the data when you update. Might take a few seconds to load, but you now have the new graph. There are also ways to freeze the data so that if you don't want it to update, I'm not going to cover this today, but I just wanted to give you a feel of the existing features. Now, before jumping to code workbook real quickly, I wanted to mention another concept set tool. So what I showed you earlier, if I go to the homepage, is this concept sets browser, which has the list of all the existing concept sets within the enclave. But let's say there is no concept set that is suited to your needs. For example, maybe there could be a concept set within the enclave that is almost exactly what you need, but you need to modify it a little bit, maybe add a few codes or remove few codes. Or you need to bring in a concept set from outside the enclave, for example, from the Atlas tool, if you're familiar with it. There's this other tool in the data catalog, which is called the concept set editor. So in the data catalog, there's this collection called dashboards and apps. And here it is, it's called concept set editor. And the concept set editor is where you can create your own concept set or modify an existing concept set. So I'll show you a quick example. If I copy, let me copy this non-influenza pneumonia training. On the top left here, you can enter an existing concept set name. And as you can see, it automatically recognized this one. If I click on use this concept, it loads it in this tool. And now that it loads it, you can actually play with it and modify the content of it. So here you have the list of all the existing concepts, 226. But maybe you want to play with it more. Maybe you want to not exclude this concept, and now we have more concept sets in it. Maybe you want to not include all the descendants. So if you don't include all the descendants, you only have 2 concepts. So this is one way to kind of play with the list of codes and edit them. Another way to do that is, well, let's say I'm not interested in this concept ID here. I can remove it. And if you scroll down, you can actually look at all the lists of all the existing OMOP concepts or codes, and maybe add some codes that you want to add to this concept set. So if I type in the keyword pneumonia, for example, here, I have a very large list of codes that, and you have some filters here and some statistics about each one of these codes. So you can choose to, let's say I want to add this code to my concept. I can click on here and click on add selected concept to expression. And if I scroll up, I see this new code in my concept set. So these are a few ways to edit an existing concept set. And once you edit it, you can write in some information here. So as to why, what are the changes of this concept set? Maybe you can have some words about the limitations of this concept set. You can have an updated message, so updated concept set. And so what you can do is you can either create a new version of this existing concept set with this content, or you can create a completely new concept set and give it a new name. So maybe new pneumonia concept set. And you can click here to create an existing concept set. The other thing you can do is, if you are familiar with Atlas and you have a concept set defined by a JSON string, you can actually copy paste the JSON in here. And if you click on reload, it will load the concept set in here. Right now, the string is empty, so it has no concept. So I went a little quickly on this concept set editor. I didn't show all the features, but I just wanted to give you a feel of how it works. And the purpose of this tool is to edit existing concept sets or create new ones that suit your need. Okay, so the last thing in this presentation that I wanted to show, and maybe I'll go quickly on it, is the code workbook. If you feel like writing code instead of using Contour to analyze your data. So let me go to my N3C orientation. And before that, Sean, should I stop for any questions, or are there any questions that I should address in the chat before moving to code workbook?
We haven't seen any questions in the chat, but never a bad time to stop for questions. I think if anyone has any, you should be able to unmute yourself.
Okay, that sounds good. Then I'll carry on with the code workbook demo. So like I mentioned here, Contour is a way to analyze data, but you can actually write code within the enclave, and the tool to do that is called code workbook. And I can create a new instance of it from here. I can also, in the left panel, click on here and create a new one. There are different ways to get to it. And so what this does is it will create a new workbook in which I can import the data and write some code. So let's give it a name. Maybe I'll call it N3C Orientation Code Workbook. And usually the first thing you do when you create a code workbook is import the data that you want to work with. So my goal for today is to do something very similar to what I did when I showed you Contour, but using code. So I'm going to import the data sets that I've used in my Contour analysis. The first one is the concept set members table. So if I go to OMOP code sets, I can click on concept set members, and this will automatically import this table in here. And as you can see, this is a graph view. And the purpose of it is when you have multiple tables and multiple transformations, you can see kind of the relationship between them and the logical succession of transformations. But right now, when you load this table, you have a preview at the bottom. You have some basic statistics in here. And I'll talk about other features in a bit, but let me import. If I click on import dataset, let me add the other table called condition occurrence. It's going to be in the data catalog, Cynthia notional data, and condition occurrence. So now I have this second table. Let me actually move it here. If I click on this just to like make them centered. Now I have two tables as starting points of my analysis. First one is concept set member, and the second one is called condition occurrence. And for people who write code using, say, Python, R, or SQL, so this code workbook supports 3 languages, either Python, R, or SQL. And for people who, let's say, did work in R or Python before, you can think of this as a, say, a Jupyter notebook or an RStudio type of tool where you can, on the right-hand side here, if I click on console, you have a console, which is like a shell where you can execute like one-off code and explore your data. But you could also write some scripts, either in Python, R, or SQL. So maybe to show a few examples, as you can see here, we have 3 consoles, one for R, one for Python, and one for SQL. And if you look at the bottom here, you have the variables that are predefined in this code workbook. So here I have imported 2 data sets, and these 2 data sets are concept set members and condition occurrence. And this is also the variable name that I can use within the code. So every data set is represented in the code by a data frame. The equivalent of it is a data frame. So something I can do here is, let's say I want to explore my concept set member in R. I can do something like head concept set members. And let's say I want to look at the first 5 rows. And so while it's doing that, sometimes it takes a few seconds, but generally it's quicker. What I can do here, or there you go. So now I have, this is just like an example of what I can do in the console. So like print the content of the first 5 rows. Maybe I can do an example in Python. I can do something like concept set members that count, which will give me the row count of concept set members. So as you can see, it's 3 million rows. So the console is to like kind of execute some quick commands to either explore your data or test your syntax or do some quick things. The other thing you can do is write some scripts. So if I click on new here on the dataset or on the blue button, new transformation, it's the same thing. It will give me the option to select the code that I want to write. So you have R, Python, SQL. You can also do some contour visualizations here, and I'll talk about templates later. But let's say for the sake of example, I'm going to select R. And so the way it works is what I've created here in this script. Let me actually minimize this and maximize this. This is a this is a function in R. And the way it works is usually when a transformation is a function that takes one or multiple data sets as inputs. And as an output, you want to return a data frame. So let's say I want to add the other input condition occurrence to my function before starting to write the function. One way to do that is I can click on add inputs and then click on the node here. So it automatically added the second input called a condition occurrence. The other way is to just start typing the name of it and it will automatically recognize it. So if I start typing condition occurrence, it will automatically recognize the table. And now, as you can see, I have 2 input tables and a transformation in R that outputs a data frame. I haven't written the transformation here yet, but this is generally how it works. So just to go quicker, I have some code that I've written for this presentation. So I'm going to paste it and then explain what it does. And so let me just delete this and paste it in here. And so what this code does is essentially the same thing that we did in Contour. So I'm starting with, I have 2 inputs, my concept set numbers table and my condition occurrence table, which are data frames. And I have my, I'm starting with my concept or code set ID corresponding to non-influenza pneumonia. And then I'm applying a filter to concept set members table to keep only the records corresponding to this code set ID in this line. And then I'm applying a join. So I'm doing an inner join with condition occurrence table on the concept ID. So the matching condition is concept ID equals to condition concept ID. So similar to what I did in Contour. Now, so in order to run it, let me actually save, I want to save the results of this transformation as a data set. So again, we're starting with 2 data frames, and then we're returning a data frame as an output. And this output is going to be written in this data set. Right now it's called new data set, but if I click on here, I can call it selected pneumonia, just like the name of my function. And I can click on run, and this will run this transformation and apply and then write the outputs on this data set. So while this is running, for people who write R, you may have noticed some like maybe weird syntax here, like this Spark R thing. So Spark is essentially a library, and to give some background, the enclave runs on top of a framework called Spark, which is a distributed computing framework that is good with it basically operates on the principles of parallel computing and distributed storage. And what I mean by that, well, actually before that, let me show the results because this finished. So here you see the logic. If you click on preview, you will see the results of your transformation. You can also open the data set in here, and then you will see the results of your code. So this is my data set selected pneumonia, just updated a few seconds ago and updated via this code workbook. And it has 17,500 rows, which, as you remember, is the same as what we had in the contour analysis. So if you write our code here, you can see the results in preview. You have the two inputs, which are these two data sets. If you have some visualization, so let's say you use things like ggplot, or if you use Python, matplotlib, or other libraries, you will see the graphs in here. And then if you're printing some logs, or if you have some errors, you would see them in this panel here. So going back to the logic, and what I was saying about Spark is the framework of Spark allows you to perform analysis on very large data sets in an efficient way. As you may have noticed in the homepage, we have some very large tables if you work with real data. And so, for example, the measurement table is almost 3 billion rows, the lab results. And so if you use just your regular R data frames, or if in Python, you use Python and then you use pandas, when your data becomes too big to analyze, you might start hitting some efficiency issues, and you might notice that your code may be slow. And sometimes even you might have some out of memory errors. If you use the library Spark, so Spark is it has a library in R called Spark R, and in Python it's called PySpark, where you can manipulate data frames, but by leveraging this Spark framework, your code will be much more efficient and you will not hit any issues with the data. And so if you want to learn more about Spark, if you click on the right-hand side here on help and support, you have the documentation that I showed earlier in the presentation. If you go to code workbook, you have and you click on PySpark reference, you have a cheat sheet here. So for people who are not familiar, if you want to get used to the syntax of using the Spark library, this is especially for Python, you have the most common operations here. So like filtering, oh, I'm sorry, I clicked on. You have filterings, you have joins, you have column operations. So the most common operations are in this cheat sheet if you want to start using Spark instead of just like regular pandas or regular R data frames. And Spark R is a similar library if you use R that you can find online, so you can look at the syntax. So that's mostly what I wanted to share. So on code workbook, maybe one last thing I want to share is I talked about this console. I talked about the editor where you can write functions. There's this thing called the global code, which is basically where you can write some either functions or import some libraries that are going to be used in all different transformations here. So let's say I have another transformation here, and maybe this time in Python, and let's call this maybe test data frame, and I'll just do something very basic where I'm doing test data frame equals selected pneumonia, and then this is what I'm going to return. Maybe selected pneumonia dot, let's select just one column. So this is Python code. Let me look at the inputs. Let's just select maybe the concept ID column. Sorry, it's called, concept ID. So let me run this Python code in here. So as you notice in a code workbook, you can have R code, you can have Python code, you can have C code. So it's a good way for people who come from different backgrounds to collaborate. But the thing I wanted to show here is at some point, you may start having multiple transformations in your workbook. And maybe in each one of these transformations, I have some imports. So like I'm importing the library matplotlib, and then I'm using it in this function. And then maybe I have another function where I also want, oops, I'm sorry. Maybe I have another function where I also need to import the matplotlib library. Maybe one more efficient way to avoid that is to put it in the global code. So in the global code, I can do all my imports. So for Python, I want to import matplotlib. Maybe for R, I want to import the library dplyr. And so what this does is anything in this global code will run automatically in each one of these nodes without having to specify it. So maybe I have a utility function here that is very common. Let's call it utility df, and I can write a function here. And I can call this function from each one of these editors without having to redefine it because it's already defined in the global code. So that's what the global code is about. The last thing, maybe if you're curious about the libraries that are supported within Code Workbook, if you click on environment and then view the resolve packages, you can see there's a large number of libraries that are supported within Code Workbook, either R or Python libraries. If the library you want to use is not within these ones, you can reach out and we can help you add it within the enclave. So since we're running out of time, I wanted to conclude by showing some the knowledge store, which is an app within the enclave that has some shared logic. So let's say if you work a lot with Code Workbook and then you write some logic and you think it's going to be beneficial to other people and researchers within the enclave, you can put it in the knowledge store and other people can reuse your logic. And the knowledge store is also good about attribution, so you'll get credit for your contribution. And so if I go to the, and this is a good way for you to see what's already been done in other research projects and see if you can reuse some of the analysis without having to reinvent the wheel. So from the home page, if you click on knowledge store, you can see here a number of what we call knowledge objects, which are basically just mostly shared logic by other people. And let me just focus on the code templates. And so there are a number of codes here. So let me click on this one, for example, which is this one is a sampling template, which was created by Sean. And it's been used in this. So if I click on this knowledge objects here, you have a title, you have a description of what it does. And then you have a README, which is if the person contributing is good about the documentation, they put a README file to explain how to reuse this logic. And then you have the thing that is actually shared, the logic that is shared. So if I click on this, this is what we call a code workbook template, which is basically a code workbook function that you can reuse. If I click on code here, you can see this is an R function that you can reuse in your code workbook without having to re-implement it. And this one is just like a basic sampling function. There are more involved templates. And one way to reuse this template is just to click on action and then using code workbook. Let's call this code workbook reusing existing logic in knowledge store. And let me save it in my N3C orientation folder. And so what you see here is I created a code workbook with this node, which doesn't look like a code, but more looks like an interface where I can specify my inputs. And if I read the description here, I can see that what I need for this table to use this template is add input a domain table, which is a data set. And then these are just like the percentage of person IDs I want to keep, basically my sampling inputs. So this is one example of templates. If you want to look at what's done, basically the code behind this template, you can click on toggle view and you can see the function that is back in it. And then once you, if you go back to logic and toggle view again, it will take me back to this interface view. So once if I import a data set and then I add it to this import, I can click on run. And this will run my template in here. And this is just a sampling function, but you have other examples in here. So this is very useful, the knowledge store, to learn from what other people have done already. You can also filter by the author of the knowledge object. You can filter by the originating research project. So let's say, for example, I want to look at all the templates that has been published by the cohort characterization project. I can do that. And I'm sorry, I have all these number of templates. So this one computes the patient severity scores. And then you have a number of examples, and most of them are good with documentation. So you can understand what's being done and either reuse it or just learn from the template. And then something that is also quite useful as a starting analysis is a template that shows you how to get all the COVID positive patients. So feel free to check this out. It has some documentation and some resulting tables that you can reuse. So yeah, that's mostly it. I think I just want to allow some time for questions if there are any questions from the audience. Otherwise, what I suggest is to feel free to check out the training materials, especially the training portal. And then if you have issues using the Enclave, you can always file an issue. So if you click on help and support, you can report an issue. So let's say you're working on an analysis or you don't understand how a tool works or a data set, you can file an issue here, or you can, for example, just ask a question or report a bug. And let's say my question is a product question. I can give it a title, and then I can maybe provide more information here. This will go to a support team that will get back to you and try to help you with your questions. So that's just one way to get help within the Enclave. Going back to my slides, so I talked about the training portal. I talked about the Academy tutorials, which are some quick ways to get up to speed, and then the more in-depth platform documentation. I also talked about filing an issue, which is another way to get help. We also hold office hours, mostly Sean and I, every Tuesdays and Thursdays from at 10 a.m. Pacific time. So that's also another way if you want to stop by and get help and get some support. And then lastly, a good way to collaborate is, again, from the homepage, there are a number of useful resources. And one of them, if you scroll down, is the domain teams page. So N3C has a number of domain teams that you can join to learn from and collaborate with. So some like acute kidney injury, imaging, etc. And each one of these domain teams meets regularly, and they have their own Slack channel and Google Drive. And so it's a very good way to collaborate and also just ask your questions in Slack. Say, hey, I'm trying to do this analysis. Has this been done before? Do you have any advice? It's a great way to share knowledge and learnings with the community. From the homepage also, we have a link to all the COVID-related publications so that you can have some information about what, among other things, what came out of the Enclave in terms of research. So that's about it. Any questions?
Hi, I didn't have a question, but I just want to say thanks for the excellent presentation. The information on using Spark and R to help with join efficiency was very helpful in particular, and I was interested to hear about the knowledge store as well. So thank you very much.
Okay, my pleasure. I know, Charles, was a lot of condensated information. And so, sometimes there could be a learning curve related to, on one hand, you want to get used to the tools. And on the other hand, maybe you also are not familiar with the data and the common data model. But hopefully some of these training materials help. In terms of performance, if you're interested in the training portal, there is a guide that gives you some good practices if you want to optimize your code, whether you're writing R or Python. So in case you start hitting some issues with performance, feel free to check that out. Although you can always reach out to us for help.
Thanks, I'll check that out. Yeah.
No problem. Any other questions?
I don't see any. Thank you, Saad, for the amazing information. And we have our office hours in half an hour. If anybody wants to stop by.
Great. Thank you all for attending again, and feel free to reach out if you need any help. I hope this was useful, and we're always open to feedback to give you more trainings and more documentations to help you get up to speed.
And I added a link to a feedback form in the chat if anybody wants to make some comments.
All right.
Take care.
Thank you all.